Okay, welcome to video 11.9. Today we're going to be talking about graphing quadratic exam and application problems. So in this first question, this was an old exam question. It says that a football player attempts to kick a football over a goalpost. The path of the football can be modeled by the function, and they give us this function h of x, where x is the horizontal distance from the kick and h of x is the height of the football above the ground when both are measured in feet. So the key information here is the function that I already highlighted and that these are both measured in feet. On the set of axes below, we need to graph the function over, and they give us this specific interval. So they are telling you that your x values need to start at 0 and only go up to 150. Now they are also giving us the number of hash marks so that I know how much I have here. So before we label, I always want to figure out, well, what could I count by in order to make it fit so that I can show up to 150. So starting at 0 and up to 150. We can do this by figure out how many marks we have, which there's 30 of them. And since I need 150 to be shown through this, I can make each one worth 5, and that'll actually fit perfectly with 150 right at the end. Now, you could count by something else, like say tens, but it's just going to be that you're not going to take up the entire graph, and it might not show the nice arc and the nice path the same way. So we're going to make sure that we stretch as far as we can, starting at the point right here, 0, 0, and moving as far on this axis as possible. And that's by counting by 5s. So I'm going to label from here to here, counting by 5s. So when I did that, I just counted and wrote every other. So it looks like I counted by 10, but if you look, each mark is worth 5. So it's 0, 5, and then 10, 15, 20. I just marked every other up to 150, and that fits perfectly going from here to here. So I think that was why I chose to count by that, and I knew that I needed 0 to 150 because of the domain that they gave me. Now, the thing is, I don't have my y values. I don't know what they are, but I have a function, and I know the x values that I care about because they gave it to me in this domain right here. So that means that I need to put this function in y equals and go to the table of values. So first, let's do that. Go to y equals in your calculator and put parentheses around the fraction. So it'll be y equals parentheses negative 1 divided by 225 end parentheses, then x squared plus parentheses 2 divided by 3 end parentheses x. If you have the older calculator, if you have the newer calculator, you can just put those as fractions. Now when you do that, if you'll notice, in the calculator, I start seeing a lot of decimals and things that don't look well. Even if I started at an x value of 0, which I know from the domain and from my graph that that's where I need to start at, when I look at that value, it's 0, 0, but then at 1, it's a decimal. And that continues for 2, 3, 4, and I keep moving. I see a lot of decimals. I don't want to try to graph any of those decimals. So I'm going to keep scrolling through to find the next nice point. And it happens at 15. At 15, the y value is 9. So that tells me that that's a good point. So then I see that that means that I really don't care about the in-betweens. I want to count by 15 and see if I continue to get nice points. So if you'll remember how to do that, you need to hit second window for table set. You need to tell the table to start at 0, and then you'll see that triangle table, which means the delta or the change in the table, and we want to change that to 15, so it counts by 15. Then if you go to the table, now we see a nice graph where I can see 15 is with 9, 30 with 16, 45 with 21, and so on and so forth, up to 150 back at 0. So that tells me that that's the table. That's what I want to count by. So we want our y values. From that table, I can see that they need to go as high as 25. So we can write that table down. So again, I copied that right off of my table once I changed the settings. And we can see that I now have the same on each side. So this is a nice parabola. I should see it come up and back down.
Now, before I can plot these points, I need to label my y's, and I can see from the table my maximum occurs here at a y value of 25. So this is my turning point. I didn't need to do the axis of symmetry or anything for this one because they told me where I needed to show. It wouldn't have mattered if this was the symmetrical part of the table or not. They told me where to graph. So I know that I need to show up to 25. And you can again count the number of marks on the y-axis, and there's 17 of them, so that tells me I can't count by 1 because I need to show up to 25. So I need to count by 2's on my y-axis. Okay, so I counted by 2's, but on the side you can see that I didn't write every number. I just showed 2, 4, 6, 8, and then where 10 would be, and then continued to show 20 and 30, and then I wrote 34 at the top just so I knew what the highest y value that I have on my graph is. Now go ahead and plot all these points. So now that you have your x and your y, give that a try, pause the video, and then continue once you have yours all plotted to see if it matches mine. Okay, so you can see all my points, and just make sure that when you're plotting like at 21, for example, that it's exactly halfway through. It's a little bit harder on the iPad, but this should really be exactly halfway between 20 and 22 because it's 21. So yours should show this similar curve going up and then back down. Now I can connect with a smooth curve. Okay, so again, yours probably looks a lot better than mine does, but just that smooth curve showing that this path going up and down. Now, the other things I need to do on my graph is label it, because right now, nothing really means much to me on this graph. So the x-axis, what are those values representing? Well, they're representing the horizontal distance in feet. So I wrote that on the x-axis. Now the y-axis, that's the height of the football, again, in feet. So that needs to be written on the y-axis. And then the title for this whole thing is, I just labeled it over the goalpost because I know that they're attempting to kick a football over a goalpost. Okay, so once you have all this information and everything labeled, you can move on to the follow-up questions. The first question here says that we need to determine the vertex. So what's another word for vertex? That's turning point. So we're looking for the turning point of y equals h of x, so the function h of x. Interpret the meaning of this vertex in the context with the problem. So above vertex, I'm just going to write turning point. So when I look at the graph, I can see the turning point. That is where it starts going the other direction. So if we look, it starts going up all the way until it hits that maximum. We already talked about this showing up in the table where the values start going the opposite direction. So my turning point is 75, 25. So I determined the vertex, but I didn't interpret the meaning yet. So what does that mean? That means that I need to look at the x and y value so I can write out in the context of the problem what each value is representing. So the 75 is representing the horizontal distance, and the 25, the y value, is representing the height of the football. So I would say that the vertex means, and I just wrote out what the vertex was in my sentence there. It means that the maximum height of the football is 25 feet and it occurs 75 feet down the field. The next question says the goalpost is 10 feet high and 45 yards away from the kick. And then it asks, will the ball be high enough to pass over the goalpost and justify? Well, there's an important piece here. They're talking about the goalpost being 10 feet high, so that tells me it's happening at a height that's 10. But then they talk about 45 yards away from the kick. So where it's first kicked over here, it is 45 yards. But this is in feet. So before I can even answer this question, I need to figure out, well, how many feet is that? So we need to change the 45 yards into feet. I could set up a whole conversion, but I know that there's just 3 feet in every yard, so if 45 times 3 will tell me how many feet that is. You could write it out with units and everything actually performing the conversion, but most people are able to just do the 45 times the 3 knowing that piece of information. So it's 135 feet down the field. That's where we need to see if the goalpost, if the kick will go through it or not. So at that 135 feet over here, I need to figure out, is the ball higher than the goalpost? Well, the goalpost is 10 feet
And if I look here, oh, but my height of the football is only 9 feet. So that means it's going to be a foot too short. The goalpost would be right here. It'll go right underneath it.
So we looked at it on the graph, but the question tells me to justify. So that means I need some math to back up my answer. So what I did was I knew that it was 135 feet down the field. That's an x value. So I need to plug that in place of x in my original equation. So that's why I wrote this with the negative 1 over 225 times 135 squared plus 2/3 times 135. This will tell me what the height of the football actually is. Then you can put this all in your calculator, remembering either parentheses around your fraction or to input it as a fraction. When you do that, you get an output of 9, which tells me that the ball will only be 9 feet off the ground. So, no, it will not. So I just wrote no, but my justification is also part of my answer here. Okay, the next question that we're going to look at says that a company is considering building a manufacturing plant. They determine their weekly production cost at site A to be A of x equals 3x squared, while their production cost at site B is B of x equals 8x plus 3, where x represents the number of products in hundreds, and A of x and B of x are the production costs in hundreds of dollars. We need to graph the production cost functions on the set of axes below and label them site A and site B. So when I look, they already did a lot of the work in this question for me. I can see my x values are already determined on the graph and my y values with what each one is standing for. So on my x-axis, I'm going to put number of products in hundreds, and on my y, we have the cost in hundreds of dollars. So when I look up in my question, I can see the two functions. So I'm going to highlight those. So A of x is, I just highlighted in blue, and then B of x in purple. So those will match my tables. Since I know what I'm graphing and I know the values that I care about, I can just go right to my calculator and plug in y equals and then the 3x squared. Then hit second graph to look at those values and write down the table that goes with it. So I can see I just wrote down A of x equals 3x squared, and then the x and A of x standing for the y values for the A of x function. So the first value that I see is 0 is with 0. And then I know that the x values I want to look at are 1, 2, 3, and 4 because those are what are on my graph over here. So I'm going to write down those values, 0, 1, 2, 3, and 4. So hopefully your values match what I have here from my calculator. So 0, 3, 12, 27, and 48. Let's plot these points so I can see what my A of x looks like on the graph. So I've plotted my points keeping in mind that they are counting by twos, so any odd numbers needed to be directly in between. And then I can connect with a smooth curve and put a label on this, labeling it site A. I'm sure that yours will look a lot better than mine, but do your best to just connect with that curve, labeling it and showing that it's going up in a curve fashion here. Now I'm going to do the same thing for B of x function. I'm just going to write down my table for B of x as well. Then once you have those points, hopefully you get the same ones that I do with the y values 3, 11, 19, 27, and 35. You can go ahead and plot those points, and this time we can connect with a straight edge to show that this is a linear function. So there's not a curve needed, it's one straight line. So now I have both my graphs, they're labeled, and I can see where they intersect, and I put a bigger circle on there so you can see that this is the point that is on both of those graphs. Now we can go ahead and look at the follow-up questions. So this question says, state the positive values of x, which we only see positive x values here. That's just telling us that since this is a parabola, it'll probably come back up the other direction. I'm only caring about positive values. At which the two sites are equal. So when will they be the same? And explain how you determined your answer. Well, if I look back, we already talked about when they are the same, when will the cost be the same? Well, that's where they intersect. At this x value right here of 3, I can see that they have the same cost in hundreds of dollars. So I just wrote that my answer is 3, which means 300 products. I found my answer by looking for the solution because the cost is equal at this x value. Okay, the next question says, if the company plans on manufacturing 200 products per week,
Which site should they use and justify your answer? So I'm going to look back at my graph and my table. So I'm just going to move this back up a little bit and say, okay, well, if we know that they're going to have 200 products for the week, I need to look at the 200 number of products. So which company will be better if that's the case? Well, I want the cost to obviously be as low as possible. So this blue function has a lower cost at 200 products compared to the purple function on my graph. The justify means I should probably look at my table so I can give an accurate justification. So at that x value of 2 that I can see on my graph, I'm going to go over to my tables to say, okay, well, at a of x, the cost is $1,200. And for my linear function, the b of x, at 2, it's $1,900. So I just wrote that out as site A because the cost will be 12 hundreds of dollars, which means $1,200, compared to the 19 hundreds of dollars, $1,900, and the company would want the lowest cost. Okay, that's it for this video. Have a good night.